exploring the laws of motion with a simple pendulum objective. In this experiment, we will study the motion of a simple pendulum to understand how its period depends on the length of the string and the effect of gravity on its motion. This will help us learn about periodic motion and verify the relationship between pendulum length and time period. Materials needed: a small dense bob like a metal ball or a heavy washer, a long thin string, about 1 meter, a sturdy stand or support to hang the pendulum from a protractor to measure angles, a stopwatch or timer, a ruler or measuring tape, a notebook and pen to record observations. Procedure 1. Setting up the pendulum. Tie the bob securely to one end of the string. Make sure the knot is tight so the bob doesn't slip. Attach the other end of the string to the stand so that the bob can swing freely without touching the ground or any other surface. 2. Measuring the length. Measure the length of the pendulum from the point of suspension where the string is fixed to the center of the bob. Record this length in your notebook. 3. Initial angle. Using the protractor, pull the bob gently to one side so that the string makes an angle of about 15 degrees with the vertical. This small angle ensures that the pendulum follows simple harmonic motion. 4. Starting the motion. Release the bob without pushing it, letting it swing naturally. 5. Timing the oscillations. Using the stopwatch, measure the time taken for the pendulum to complete 10 full oscillations. A full oscillation means the bob moves from the starting side to the opposite side and back again. Record the total time. 6. Calculating the period. Divide the total time by 10 to find the time period of one oscillation. Write this down. 7. Repeating for different lengths. Change the length of the string to different values. For example, 20 centimeter, 40 centimeter, 60 centimeter, 80 centimeter, and 100 centimeter. And repeat steps 3 to 6 for each length. Record all your results carefully. Scientific explanation. A simple pendulum swings back and forth due to the force of gravity acting on the bob. The motion is called periodic because it repeats in a regular cycle. The time it takes for one complete swing is called the period, T. According to physics, the period of a simple pendulum depends mainly on two things: the length of the pendulum, L, the acceleration due to gravity, G. The relationship is given by the formula. This means the period increases as the length increases, but gravity stays constant on Earth. The angle of release should be small, so the pendulum exhibits simple harmonic motion, which this formula assumes. Expected observations. The longer the string, the longer the time period of the pendulum. When you plot the square of the period, T2, against the length, YL, you will get a straight line indicating a proportional relationship. The pendulum swings smoothly and consistently if released from the same angle each time. Conclusion: this experiment shows that the period of a simple pendulum depends on the length of the string, but not on the mass of the bob or the amplitude, as for small angles. The results align with the theoretical formula for the period of a pendulum, confirming the laws of motion and simple harmonic motion principles. Understanding this helps explain many natural phenomena, from clocks to the behavior of swings. Thank you for watching. Try this experiment yourself to see physics in action and deepen your understanding of motion.